Hi, I'm Kieran. I'm an engineer at Codethink, and today I'm going to be talking to you about Hamza, which is the software that we've written to control this robot hand here. It's a fully open source robot hand, so the idea is anyone can download it and print it, put the servos in, and have an operating working hand. It's also got a little camera in the palm here. So the software for this hand can be divided into two sections. First is like the firmware to actually move each servo, i.e. each finger. And that's a C++ library that we've then bind into Python. And then the second part of the software is to enable a mimicking demo, where the hand will copy one of 5 gestures that it sees through the camera. So these 5 gestures can be open palm, fist, peace, one finger pointing, and OK. Before we start installing the software, we first need to do a bit of calibration. So what this means is we need to work out what servo position corresponds to a finger being as extended as possible. So like the maximum left wiggle for a finger and the maximum right wiggle for a finger. We need to work out what servo position corresponds to the finger being fully curved and what position corresponds to it being fully out and outwards. So we've written a document here to go through that. You're going to need to use the Windows GUI that you used earlier whilst building the hand to work out these measurements, and we've done some detailed descriptions of how you can do this. And then you need to take a note of all of those values, of all those servo positions, and then we'll use them later as we're installing the software and calibrating it. Okay, in this section I'm going to explain how to install the software. So the firmware side of the software is quite light. You could clone the repository if you wanted to and compile it yourself. But the actual mimicking demo uses an image recognition model that has a whole tree of dependencies that could be a bit annoying to install yourself. So we've created an image for you that you can download and then flash it onto the micro SD card that will go into the Jetson Nano. So this is our recommended procedure. So you can go to the guides and you can find the link for the image here. You can click it and download it. I won't do that because I've already done that. And then you'll want to use a tool such as Etcher to perform the actual flashing of the SD card. So let's go to Etcher. Yeah, you'll need to download it for whatever operating system you're using. Again, I've already done that. So having downloaded it, I now go to the directory where I downloaded it, I unzip it, and then I run what was contained within there. Okay. Now I'll take my SD card, I'll pop it in to my laptop. If you don't have a port for reading SD cards, you'll want to use a little USB adapter like this one. Okay, then I'll do flash from file. I will then choose the image. I will select the target. For me, it comes up as dev MMC block 0. Select, and then I'll do flash. That might take a while, so be patient. And then, yeah. Okay, then once you've done that, you'll want to pop out the SD card. Put it in the Jetson Nano. It will go at the back of the Jetson Nano on the underside of the heatsink. And then you're ready to boot it up. So in order to boot up the Jetson Nano, you need to plug in the power cable. We're using the micro USB cable. You'll need a keyboard and maybe a mouse in there as well. So we've plugged those in. They're wireless, but you can of course use a wired keyboard and mouse. You'll need to plug in a monitor into it. We're using the HDMI port. Once you boot into the Jetson Nano for the first time, you'll be taken through a series of prompts to configure your username and password, the location and all of that, as well as the partition size on the SD card. Probably the defaults will work for you just fine for all of that. And then once you've got through all of that to the end, you'll be ready for the next section. Okay, so you've flashed the SD card, you've got the Jetson up and running, we're nearly ready to start having fun. But first, we've got to slightly calibrate the firmware for the robot hand. So this is detailed here in the guides. And as you can see, it says we need to open up source cpp finger.h. So let's open up our file browser. Let's go to Robot Hands. So all the software required for Hamza and for the demo is in this directory, Robot Hand. Let's go to Hamza itself, go check out the C++ library, and go into finger.h. Okay. So these values here, previously you will have hopefully made a note of the ranges of the servos for each finger, for curling and for wiggling. So now is the time to write those ranges into this file. For us, we've already tuned the ranges, but actually these IDs got a bit mixed up. So I'm just going to swap the IDs for the pinky servos. Okay. Save it. Close it. Close that. And now, having made the adjustments, we need to recompile the software. So let's open up a terminal. Let's go into the directory for Hamza, and then just perform make. Okay, so now we've got the Jetson Nano plugged in and booted up. Next, we need to connect it to the hand itself. So on this little URT board, there's a mini USB slot. So you can plug a cable in there that goes to normal USB and then pop that into the Jetson Nano itself. And you should see some lights come up on the board itself. If you see 2 lights, then that means you haven't plugged in the power source for the servos. Now let's check to make sure that works. So if you do ls/dev/tty USB 0, if it does that, so it doesn't show any errors, just repeats the path we've given it, then you know that the Jetson Nano has found the hand and called it device tty USB 0. Perfect. Now let's see how the posers are doing. So cd into robot hand, Hamza, source, and then using Python, run the following script. And now the hand is going to cycle through all 5 gestures that it knows. So we start with OK, we started with open palm, then OK, now it's doing the 1 finger point, it's doing the fist, now we've got peace, and then finish with open palm again. Beautiful. So if your hand does that, then you've got it successfully set up. Okay, let's see how the mimicking demo works now. You want to open up a console again, like I have here, and then you'll want to cd into robot hand, Hamza source again, and now open up a Python 3 console. Okay, let's start by importing sys. This allows us to tell Python where the image recognition model that we're using is contained. We're using one called TRT pose hand. So instead of typing this out, I'm just going to copy it from the web browser I have open, paste it in, boom, nice. Okay, now from Hamza, let's import the software required for the mimicking demo. This might take a little bit. We'll sit here and wait. There we go. And now let's import the firmware itself as well. And that's much quicker. Okay, having imported the model, we now need to load it into RAM, if that makes sense. There's a difference. So let's call it hand model equals mimic.get pose model. Now, this one can take a little bit longer, maybe a minute or so we're just going to skip ahead. Okay, we just got a little warning while this model was running, complaining that one of the cached files on the image was compiled on a different device. So the other device we used was a Jetson Nano. So assuming Jetson Nanos are roughly identical with each other, I wouldn't worry too much about that warning. Okay, and now it's finished, we can proceed. So having loaded the model, we also want to load the camera and a container for the image from the camera. So that's what I'm doing now. And we want to pass that, the image recognition model, so the camera knows how big to make the images. You'll get a little bit of output from this as well. There we are. All right, now let's create an instance of the firmware. That allows us to actually individually control each finger. There we are. And now we've got everything we need to actually run the mimicking demo. Ooh. You'll notice that my Jetson Nano is running very slowly because the image recognition model takes up a lot of RAM. So be aware of that. Okay, and so to run it, we do run mimic. Model, camera, and camera. Boom. So the first thing you'll get outputted is a list of all the possible gestures that you can do. And then now it's started trying to detect things. So it can't see a hand right now because I'm not showing it one. So it decides that it can see pan, which is the word for pointing upwards. Don't worry too much about that. Hopefully when we show it a hand, it'll actually realize what's going on. But before I start showing it hands, I'm just going to open up a little window where I can see what the camera is seeing itself. So I'm going to do Control-Shift-T to open up a new tab. And then I'm going to use FAIR. It should be already installed on the image to view Hamza source, check JPEG. And there now you can see we've got a small little window showing me exactly what the camera can see. So I'll just move my head out of view, put my hand in, and there you go. It can see my hand. Now let's try OK. When you do OK, it's nice to try and show the camera as much of the circle here as you can. It helps it realize it's OK. Let's try fist. There we go. Let's try piece. Try pan or pointing. Very nice. Let's go back to open palm. And you can actually see on the console, it displays below possible gestures the current gesture that the hand can see, which might be useful if, for whatever reason, you can't use FAIR to view the images. Try piece again. Open palm again. Fist. Okay. Oops. Piece. There's piece. And then open palm. And then when you're done, just come to the console where the demo is running and do Control-C. And it will shut down. And then you could run the last command again if you wanted to restart the demo, or if you're ready to finish, you can do Control-D to close down the Python console. Right, so the Python console has finished closing. You can see it didn't close cleanly. It ended with a segmentation fault. Not sure why, but the important thing is that it's removed the image recognition model from RAM and freed up the Jetson, basically. That's what we wanted to do, and it's done that. And so there you are. There's how to start and end the mimicking demo. Lastly, I'm just going to talk about how the firmware works in a bit more detail. So for those of you that want to go beyond the mimicking demo and start controlling the hand in your own customized ways. So again, let's go into robot hand, Hamza source. Let's do Python 3, open up a Python console. And then again, we'll need to be from Hamza, import firmware. Right, and then just like with the mimicking demo, we'll also want to create an instance of the hand. Right, okay. And then now from this variable that we just created, hand, we can individually control every finger. So for each finger, there are two servos, one for curling the finger and then one for wiggling it from side to side. And so accordingly, for each finger, we have two functions that you can call. So the syntax for these functions is like, so you do hand dot, let's say you want to curl the pinky. You're going to write curl pinky, and then you're going to specify how much you curl it. So that's going to be a number between 1 and 0. where 1 corresponds to it being pointing fully up, and 0 corresponds to it curling fully inwards. So let's say we want to curl it halfway. Then we'll do 0.5. And then now you give it how long you want this process of curling to take. So this is a number in milliseconds. So for example, if you want it to take a second, you're going to write 1000 here. And then you press enter, and it nice and slowly curls the pinky. And then we can keep going to curl it all the way by changing this 0.5 to a 0. And there you are. Right. And now for the other fingers, it's very similar. You just replace this word pinky with either ring for the ring finger, middle for the middle finger, index for the index finger, or thumb for the thumb. So as a demonstration, let's do middle 0.7, and let's show you it going quite quickly. Actually, not going to make that 0.1. Let's show you it going quite quickly. But all right. Okay, and so I said before that there are 2 servos per finger. So that was, I've shown you how to use the curling servo. Now let's look at the wiggling. So it's dead simple again. You just use the same functions we were doing before, but replace the curl with wiggle. So for example, if you want to wiggle the index finger, we change that to wiggle, we change that to index. Okay, but now for wiggling, this number between 0 and 1, it obviously doesn't correspond to fully out or curled in. It now corresponds to wiggling. So it's actually written here in the README. So 0 corresponds to the thumb being fully to the left, i.e. furthest away from the thumb as possible. And then 1 is going to correspond to it being over there, as close to the thumb as possible. So we can wiggle the index finger. I've spelled wiggle wrong. Have I? 2 G's? Maybe? Let's find out. So let's do that. Okay, and it was quite subtle, but you may have seen that the thumb has wiggled a bit further towards, the index finger has wiggled a bit further towards the thumb. And then if I change that to 0.9, for example, it's gone the other way. And then I put it back to 0.5, so it goes into the middle, and there you are, okay? And then I can show you that with another finger just for fun. So let's try with the thumb. Let's make it a bit slower this time. Thumb index. Sorry, I wrote that completely wrong. It should be wiggle thumb here. Press enter, and you see that, well, hopefully, I don't know if the angle works, but you should hopefully see the thumb slowly curling there. Wiggling. Bring it all the way around by changing that 0.5 to a 1. And then we can bring it all the way back, but nice and quickly this time. And there you are. And then the last thing to talk about is the wrist. So as I described, you've got 2 servos for every finger, and then there's this last servo at the bottom for the wrist. So that is just one function, because there's no distinction between curling and wiggling for the wrist. So we've just wrote a function called curl wrist. And so, again, very similar syntax. The number between 0 and 1 obviously now corresponds to how far it's moving back and forth. So 1 means that the wrist is as pointing the hand as far away from you as possible, and then 0 means that it's pointing. Okay, and with those functions, you now have everything you need to fully control the robot hand. Have fun.